Okay. Here I give an example of one non-parametric test, the so-called Spearman Rank Correlation coefficient. There is a couple of rank testings, and what is done here is that before we were always computing on absolute data values. X is 10 and Y is 9. And if you go back to our example here, yeah, let's assume this value would have been here. Yeah. Then or it would have been exactly on the mean values. Then it would contribute 0 to the correlation coefficient because delta x and delta y is 0. So the absolute distance from the mean values matter. That's why this correlation is also heavily affected by outliers. And all these rank correlation tests are trying to circumvent this problem by transforming the data from absolute numbers to a rank. And what I'm meaning by this is most easily shown on an example. So this is our data that we use now for the test. And these are the numbers. And I already sorted them so that x is in increasing order. Now, first of all, what I do is every single x value is assigned a rank. I start with rank 1 for the highest x value, and the lowest value is then the number of data points. Yeah? So I just number them through, and this gives the rank. Now, let's assume this was not 980, but 90,800. Yeah? Then it would still have the same rank. It doesn't matter how far away it is, just that it's the largest number. And the same is also true for y. Now here are some problems which can also occur for x. If I start ordering them, so this one gets the rank number 1, it's the largest y value. This one gets the second one, okay. This one gets the, oh wait, this y value occurs twice. So since this value occurs twice, I can either say, okay, this is rank number 3 and this is rank number 4 and the other way around. But that's not correct because they have the same distance. They have the same rank. So what I have to do is, what I have to do is I correct the rank by taking the mean value of all the ones that have the same numerical rank. Okay? If we go back here, there's a second example because the 1 occurs 3 times. So 5, 6, and 7, and if I take the mean value, this is 6. So they all get the same rank. Yeah? And then we continue with 8, 9, and 10. Yeah? And this is the same data plot as before, but not in terms of absolute x and y values, but in terms of rank coordinates. And what you note is that the correlation is conserved. Yeah? Okay. And then I'm computing, this is the test statistics for the Spearman rank, so the Spearman correlation coefficient, and what I need to compute is the difference between x and y rank, and then square it. So here this is the distance, and if I square it, these are the numbers. And if I add them up, I get 285.5. And then divided by the sample sizes and so on gets me a Spearman rank of correlation of 0.73. Actually, let's see, that's 1/3, 6 times. That should be a negative. Is this a negative number? I think it should be. Yeah? Okay, ja, it should be negative. Also das funktioniert so nicht. Okay. And now I need to test against against the Spearman rank statistics, and that's usually looked up in some tables. So for degrees of freedom of 8, because we have 10 data points, 10 minus 2, so 8, we get, for a 5% significance level, we get values of 0.738. If our Spearman rank is larger than this, we are pretty sure, yeah, that so in other words, having found this, there is only a 5% chance that this is a random event. So we are 95% sure that we found a pretty strong correlation. Yeah.